Welcome to this night's homework. The normal curve can be seen on page 87, but I just wanted to show you and highlight what the normal curve is, so even if you missed it. You need to memorize all these percentages within the curve. The mean is in the middle, and the normal curve tells you 1 standard deviation, 2 standard deviations, and 3 standard deviations to the right, and also 1, 2, and 3 standard deviations to the left. In a normal curve, it takes up 100% of the data. So what that means is all these percentages should add up to 100, and they do. Now, the mean is right here in the center. It's at the 50th percentile. So at the top, I've written your percentiles. Now, we know this is from the empirical rule. We know that 68% of all data is within 1 standard deviation of each other, which means 68% is right there in that area. If you add up 34 and 34, you get 68%. We know 95% is within 2 standard deviations. 13.5, 34, 34, and 13.5 give you 95%. And we know that 99.7% of the data is within 3 standard deviations. If you added all those up, it'd be 99.7. In the tails, outside of 3 standard deviations away, is 0.15 and 0.15, which adds up to give you the 100%, which is what the curve is. Now, there will be some problems. Problem 5 is just asking you, talking about rolling a die, and it just wants you to try that in the calculator, okay? Now, what you think the distribution should look like is if you roll a die, it should all be even, right? They should all be the same. Every roll of the die has the same chance of landing on the side. But what actually happened when you simulated it on your calculator may be a little different. So I'd like you to try it at least 3 times and see how many it landed on each number and write that down for number 5. Okay, but 6 through 9, those cover this empirical rule that we were talking about. In problem 6, it tells you that the distribution of heights of adult men is approximately normal. So that means we can use this normal curve with a mean of 69 inches. So that means the mean is 69. That means 69 inches goes right here in place of the mean. Standard deviation is 2.5. That means add 2.5. So this would be 71.5. Continue across. And then subtract 2.5 for each standard deviation. So you can write in your inches. Okay, and all I ask you to do is draw the curve for number 6. Now in class we did number 7, which dealt with number 6, so you should be able to draw the curve. Then in number 7, it wants you to use this rule. In part A, it says what percent of men are taller than 74 inches? So go to where 74 inches would be, which would be about right here, and see what percent are taller than 74 inches. Just add up your percentages in the curve. Where did the middle 95% fall? Well, we know the middle 95% is between 2 standard deviations on each side. But how many inches is that? If you've labeled your curve from number 6, then you should be able to get that. Between what inches do they fall? And then what percent of men are shorter than 66.5? 66.5 was 1 standard deviation to the left. So how many are shorter than that? Add those up. And then 71.5 inches, which is 1 standard deviation above the mean, corresponds to what percentile? So that means add up all the ones to the left of it, and at what percentile is it at? Okay, so that takes you through 7. Number 8 talks about IQ scores. The IQ scores have a mean of 110 and a standard deviation of 25. So if you'll look here on the board, we've already done some of it, but if I have a mean of 110, standard deviation of 25 means I just add 25 to each one and subtract 25 from each one. So there's my numbers for the standard deviations. If I add 25, I get 135, then 160, then 185. If I subtract 25, I get 85, 60, and 35. Now, about what percent of people have scores above 110? So 110 is the mean. How many have scores above that? Okay, think about it. What percent have scores above 160? So 160 is 2 standard deviations above the mean. How many have scores above that? What percent of people? And then in what range do the middle 95% fall? Remember, the middle 95% is within 2 standard deviations. What range of scores is that for IQ? Again, pretty easy questions. Problem 9 says find the distribution of women is discussed in example 2.3. Find the percentiles of the following heights. So for number 9, example 2.3 is over here. Women have a mean of 64.5 and a standard deviation of 2.5. So women, we erase these that we had for the IQ problem. Women, theirs, and you're going to need to draw the curves on these problems, so make sure you're drawing the curves. But women have a mean of 64.5, and the standard deviation is 2.5. So that means it's going up by 2.5 each time. Sorry, I did 64.25. That's 67, 69.5, and then 72, 62, 59.5, and then 57. So that's 2.5 each time. Okay, so then it wants to know the percentile. The percentile is those numbers at the top. What percentile you were at. Kind of like on your end of course test or your end of grade test in middle school and in elementary school. What percentile did you fall at? That means you're better than what percent, which means you're whatever percentile you're at. If you're at the 84th percentile, what I'm saying is you're better than 84%, or you scored better than 84% of the people. So the 64.5 inches, what percentile is that at the top? 59.5 inches, what percentile is that at? 67 inches, what percentile is that at? And then 72 inches, what percentile is that at? That takes you through number 9. Okay, so that's 5 through 9. Then we go to 12 and 13. 12 and 13, again, using the same rule. This time the mean was 22.8, and it went up by 1.1 was my standard deviation. So again, you add 1.1 to each one. That's 23.9, 25, 26.1. That's 21.7, 20.6, 19.5. So it just goes by 1.1 each way. You need to draw a new curve on each problem. Now remember that, okay? And it asks you a couple questions on that that you can easily get. Make sure you're careful on the questions. Number 13 talks about human pregnancies. The mean's 266 and the standard deviation is 16. So with a mean of 266, it goes in the middle, and 16 is my standard deviation. That means I'm adding up by 16 each time and going down by 16 each time. And there's my numbers, and I can answer those questions on 13 from there. Okay? All right, moving on to number 19. Question 19 says SAT versus ACT. It wants to know somebody scored a certain score on the SAT, somebody scored a certain score on the ACT. It will give you the mean and the standard deviation. So this is where Z-scores are going to come into effect. So now we're learning Z-scores. Z-scores are X minus the mean over the standard deviation. That's how you find a Z-score. And you do have to do X minus the mean first, divided by the standard deviation. That gives you a Z-score there. Now a Z-score is going to tell you this. What it's going to tell you is how many standard deviations above or below the mean you are. And so basically, on the SAT, Eleanor got a 680, so that was her X. And we know that the mean of the ACT was 500 with a standard deviation of 100. So that would be her Z-score on the SAT. And then on the ACT, we have Gerald taking it. He scored a 27. The mean was 18 with a standard deviation of 6. So there's Eleanor's Z-score. There's Gerald's Z-score. Now, who had the higher score? So who had the higher Z-score is what we're looking at. Now, if we want to do percentiles, we can tell what percentile they're at after we get their Z-score. After we get their Z-score, we can take the calculator and we can go to normal CDF. Okay, normal CDF. How do you find that? You go to second distribution, and you can go to normal CDF, and the lowest number, or your lower, will be negative 999. That means you go as low as you can go. And your upper number is your Z-score. So whatever the Z-score is the upper number. That, when you type it in the calculator and hit enter, will give you the percentile that they're at. So you'll know how high they scored compared to their competition, or what area, like what level that they scored at. Okay? So that takes you through that one. Now we move to 21 through 24. 21 says use table A. Table A is at the front of the book to find the proportion of observations from a standard normal distribution. So basically, you're going to look at the Z-scores in the front of the book. Now, in the front, it tells you Z's on the very front cover It gives you all the negative ones. On the back of that, it gives you all the positive